Have you ever wondered what separates an architectural masterpiece from a global disaster? Sometimes it's just a forgotten button in an elevator or an extra centimeter in the blueprints. Today, we'll take a journey through the most expensive and ridiculous failures in construction history. You'll see skyscrapers that spit out windows onto passers-by, bridges that dance in the wind, and hotels that can fry tourists right in their lounge chairs. This is the story of how the ambitions of the world's best engineers were dashed by harsh reality and simple inattention. Fasten your seatbelts. We are about to begin a hit parade of construction madness that you won't believe until you see it with your own eyes. Imagine a glittering golden colossus towering over the sunny coastline of Benidorm. The in-tempo skyscraper was intended to be a symbol of the triumph of Spanish architecture, a living embodiment of luxury and technological breakthrough. Two gigantic towers, connected at the top by an inverted cone resembling a huge diamond, promised their residents breathtaking views. However, this project went down in history not as an architectural masterpiece, but as one of the most absurd and controversial construction embarrassments of modern times. The history of in-tempo is a series of disastrous management decisions that led to an absurd situation. The building was originally designed as a modest 20-story residential complex. As such, all engineering systems, including elevator shafts and mechanisms, were meticulously calculated. But at the height of the construction boom, the developers' ambitions prevailed over common sense. It was decided to more than double the tower's height, to 47 stories. This decision was made on the fly, after the foundation had already been laid and the lower floors were just beginning to take shape. In the rush to secure profits and the title of the tallest residential building in Europe, there was an incredible breakdown in communication between the architects, engineers, and construction workers. An urban legend, which quickly spread across the world's media, claimed that the designers were so focused on expanding the residential space that they simply forgot to allow space for elevator equipment capable of servicing a building of such height. Elevators for 20 floors take up far less space than the complex high-speed systems needed to reach 200 meters. At some point, workers allegedly discovered that the shafts simply couldn't accommodate the bulky counterweights and motors for the high-rise elevators. Although officials later tried to deny the complete lack of elevators, there's no smoke without fire. The reality turned out to be no less harsh. Due to design flaws, the elevators were operating with severe interruptions, and on the upper floors, space was so cramped by poorly designed utility lines that the building's proper operation was in question. Construction was plagued by worker injuries, freight elevator collapses, and the financial ruin of the developer. Imagine the faces of the investors who shelled out millions of euros for apartments on the 45th floor, realizing that the path to their sky castle could turn into a grueling stair marathon. This concrete giant stood for years as a half-empty monument to human arrogance, a reminder to all builders worldwide: if you decide to reach for the stars, first make sure you have enough room for the cable. Let's move on to the next fact. Imagine lounging by the pool of a luxury Las Vegas hotel. The sun warms your skin, the ice clinks in your glass, and suddenly you feel the temperature around you soar. It's not just the heat of the Nevada desert, it's an invisible, concentrated beam that literally roasts everything in its path. Welcome to the Vdara Hotel, a building that, by pure chance, has become a giant parabolic mirror aimed at unsuspecting tourists. The hotel's architectural design looked flawless on paper: a graceful curve of glass facade, panoramic windows, and a futuristic look. However, the architects overlooked one critical factor: the physics of light reflection. Due to the concave shape of the south facade, covered in mirrored glass, the building began to act like a giant lens. At certain times of the day, the sun's rays, reflecting off hundreds of windows, focused into a single narrow point directly onto the relaxation area and pools. Guests began complaining about strange things. One guest described feeling a sharp burning sensation on his scalp, followed moments later by a burning smell. The beam was literally melting his hair. Plastic cups turned into shapeless puddles, nylon bags charred, and sun loungers were burned through. Hotel staff jokingly dubbed this phenomenon the Vdara death ray. The temperature in the focal area was 20 to 30 degrees higher than the surrounding area. Engineers were forced to urgently find a solution to this hot situation. At first, they tried installing huge blue umbrellas, but the beam was so powerful that it was no help. Ultimately, they applied a special non-reflective film to the glass, which diffused the sunlight. This incident served as a harsh lesson for all modern architects. The pursuit of aesthetics and reflective surfaces can turn a cozy hotel into a death trap, where instead of a tan, you end up with a real roast. Let's move on to the next mistake. The tragedy that occurred in Kansas City in 1981 is still studied in engineering schools around the world as the most striking example of the consequences of even the slightest deviation from design and inattention to detail. The Hyatt Regency Hotel was the pinnacle of engineering at the time. A vast, multi-story atrium spanned by graceful suspension bridges at various levels. These walkways seemed weightless, floating in midair, creating a sense of space and lightness. But this lightness concealed a design flaw that cost hundreds of lives. On the evening of July 17th, a tea dance competition was held in the hotel atrium. Around 1,600 people gathered below, and dozens of spectators filled the suspended walkways on the second and fourth floors to watch the dancing couples from above. Music, laughter, and a festive atmosphere instantly gave way to the roar of rending metal. The fourth-floor walkway collapsed directly onto the second-floor walkway, and both multi-ton structures fell on the heads of the people in the lobby. When investigators began examining the debris, they discovered something astonishing. The original design called for long steel rods to pass through the upper walkway beams and support the lower walkway. However, the contractor, finding the installation of such long rods too complex, proposed a rationalization, dividing the rods into two parts. As a result, the load on the upper walkway beams doubled. The support nuts literally pierced the metal of the beams like a knife through butter. The most terrifying part of this story is that the engineers approved the changes to the drawings over the phone without even recalculating the load. They thought it was a minor detail, an insignificant fastener detail. In reality, they created a death trap. The Hyatt Regency tragedy forever changed the standards of engineers' responsibility. Now any signature on a drawing is tantamount to an oath that the structure will hold. This mistake demonstrated to the entire world: in construction, there are no unimportant nuts and bolts. Let's move on to the next fact. Imagine a futuristic glass and steel skyscraper, rising 197 meters above San Francisco's financial district. The Millennium Tower was conceived as a luxury residential complex for Silicon Valley's tech elite, a place where penthouses cost tens of millions of dollars. But today, the building is better known by the derogatory nickname the Leaning Tower of San Francisco. It turns out that even the most advanced technology is powerless against a foundation error. The problem was discovered when the building was already fully constructed and occupied. Residents began noticing strange things. Apartment doors began closing on their own, cracks appeared in the basements, and inexplicable metal creaking could be heard in the hallways. An examination revealed shocking results. The skyscraper wasn't just settling, it was literally sinking into the soft coastal soil. Over the course of several years, the tower had sunk more than 40 centimeters into the ground and was leaning half a meter to one side. What was the miscalculation of the construction geniuses? The engineers decided to skimp on the foundation. Instead of driving piles deep into the bedrock that lies 60 meters beneath the city, they anchored 25-meter piles in a dense layer of sand and clay. They believed this would be sufficient to support the weight of the enormous structure. However, under the tower's colossal weight, the soil began to act like a sponge compressed by hand. The building slowly but surely began to sink into the mud. The situation turned into a legal and engineering nightmare. While lawyers sought to sue the developers and city officials, engineers were forced to develop a $100 million rescue plan. The plan was to literally jack up the building by installing new piles down to the bedrock. Imagine the scale of the task, supporting a falling skyscraper while workers dug tunnels underneath. This incident served as a reminder to developers worldwide. You can skimp on anything: finishing, furniture, lighting, but if you skimp on the foundation, the earth will eventually come calling. Let's move on to the next fact. Imagine living in the center of modern Manchester, and every time a strong wind picks up, the entire city is filled with a chilling sound. It's not the howling of chimneys or the rustling of trees. It's a piercing, rumbling hum, reminiscent of the soundtrack to a movie about the end of the world or an alien invasion. The source of this sound is the Beetham Tower skyscraper, the pride of the city, which, thanks to a tiny architectural detail, has been transformed into the world's largest musical instrument, playing the devil's music. The problem lies at the very top of the 168-meter building. To give the skyscraper an aesthetic finish and conceal the technical equipment on the roof, architect Ian Simpson designed a graceful glass comb, a thin extension of the facade rising above the roofline. Visually, it was stunning. The building seemed to dissolve into the sky. But as soon as the wind speed exceeds a certain threshold, this glass fin transforms into a giant flute. Air passing through the narrow gaps between the glass panels begins to vibrate, creating a resonance at a frequency of approximately 250 Hz. The sound is so loud that it can be heard several kilometers away from the building. Local residents describe it as an unbearable hum, impossible to escape even behind closed windows. Videos regularly appear on social media of people recording this skyscraper howl, wondering if the zombie apocalypse has begun. The most ironic part of this story is that the building's architect lives in a luxury penthouse on the top floor of the same skyscraper. He was forced to personally apologize to the city residents for the unintended acoustic effect. Engineers attempted to solve the problem by installing special acoustic dampers on the glass fins and adjusting the angle of the panels, but they were unable to completely overcome the physics of sound. The wind still finds a way to make the building sing. This mistake became a classic example of how form can clash with aerodynamics. The builders created a visual masterpiece, but forgot that a building should not only be pleasing to the eye but also able to remain silent in adverse weather conditions. Let's move on to the next fact. Imagine walking down a busy Boston street when suddenly, right in front of you, a huge pane of blue glass plunges into the sidewalk like a giant guillotine. This isn't a scene from a disaster movie, but the harsh reality faced by city residents in the 1970s. The John Hancock skyscraper, designed by the great architect I.M. Pei, was intended to be an icon of minimalism, a mirrored monolith reflecting the sky and the historic church across the street. However, soon after completion, the building began to literally crumble before your eyes, expelling windows weighing 200 kilograms each. The problem lay in the then innovative insulating glass units. Engineers wanted to achieve a perfectly reflective surface, so they used double-paned glass with a metal interlayer between them. But they failed to account for differential thermal expansion. In the sun, the outer pane heated up, while the inner pane remained cool. This created enormous stress, and the lead binder failed, causing the glass unit to simply shoot out of the frame. During days of strong winds, the situation became critical. Police closed the streets around the building, and passers-by made short dashes under the protection of awnings. The situation reached the point of absurdity. At one point, more than 5,000 window openings had to be covered with sheets of plywood painted black. The skyscraper, which was supposed to be a symbol of transparency and light, turned into the world's largest plywood palace. Residents wondered which window would fail next, even taking bets. Ultimately, the developer was forced to replace all 10,344 panes of glass with single-pane tempered panels, costing an incredible $7 million at the time. But the troubles didn't end there. While they were working on the window issue, engineers discovered an even more terrifying fact. The building's shape made it extremely unstable. In strong winds, it swayed so violently that office workers on the upper floors literally became seasick. To prevent the skyscraper from collapsing, 2 gigantic counterweights, each weighing 300 tons, had to be installed. This incident forever changed the design of glass facades, proving that beauty isn't worth having it fall on people's heads. Let's move on to the next fact. Imagine a grand steel and concrete structure spanning the Tacoma Narrows. In 1940, this bridge was considered a triumph of engineering, the third longest suspension bridge in the world, graceful, flexible, and incredibly long. Its builders affectionately nicknamed it Galloping Gertie because, even during construction, workers noticed a strange phenomenon. With the slightest breeze, the roadway would begin to rise and fall smoothly, as if the bridge were breathing. Drivers even made special trips there to experience the thrill of the car ahead, either disappearing in a wave of asphalt or soaring above the horizon. But on November 7, 1940, the bridge's breathing turned into its death throes. The wind that day wasn't hurricane force, only about 40 miles per hour. However, this was enough to trigger a phenomenon later known as aeroelastic flutter. Instead of the usual vertical oscillations, the bridge began to twist. The gigantic, 1.5 kilometer long steel structure writhed like a rubber band. Imagine the horror of Professor Bert Farquharson, who was on the bridge at the time. The deck was tilted up at a 45-degree angle, steel cables snapped with the sound of cannon fire, and lampposts were shattered into splinters. The builders and designers made a fundamental mistake. In pursuit of elegance and economy, they used solid steel girders just 2.5 meters high, which did not allow air to pass through but absorbed all its force. The bridge acted like a giant airplane wing, being toppled by the wind. Engineers of the time firmly believed that the structure's weight was sufficient to withstand the elements and practically ignored aerodynamics. They built a sail that was simply bound to take off. The images of the Tacoma Bridge collapse became the most famous in the history of civil engineering. The central span collapsed into the water, turning into a heap of twisted metal. Fortunately, there were no casualties. The only fatality that day was a spaniel named Tubby, who became trapped in an abandoned car. This disaster forced engineers to completely rethink the physics of bridge construction. Since then, no major bridge has been designed without mandatory wind tunnel testing. Galloping Gertie showed the world that even thousands of tons of steel can turn into a paper airplane if you ignore the force of the wind. Let's move on to the next mistake. Imagine this historic moment. Two countries, Germany and Switzerland, are officially completing a grand project, the construction of a bridge across the Rhine, which will connect the two banks near the town of Laufenburg. Construction crews from both sides move toward each other, erecting powerful piers and laying concrete. It's a symbol of unity, precision, and European quality. But just as the coveted meeting approaches, the engineers are stumped. The two halves of the bridge don't meet in height. The difference is a whopping 54 centimeters. This isn't just a small gap, it's a veritable concrete step, impossible to cross. How could such experienced and meticulous builders screw up so badly? It turns out the root of the problem lay in simple human inattention and a difference in standards that everyone knew about but forgot to take into account. In surveying, mean sea level is used as the zero level. But Germany uses the North Sea level, the Amsterdam mark, as its reference, while Switzerland uses the Mediterranean sea level, the Marseille mark. The difference between these zeros is exactly 27 centimeters. The most absurd thing about this story is that the engineers knew about this difference. In their calculations, they made an adjustment to compensate for these 27 centimeters. But instead of subtracting this difference, they added it. So, instead of eliminating the error, they doubled it, arriving at those catastrophic 54 centimeters. This was a school-level arithmetic error, committed by world-renowned professionals in full view of all of Europe. To correct this monument to mathematical cretinism, the builders were forced to urgently redesign the existing structure on one bank. They literally had to cut away some of the supports and lower the bridge deck so that the two halves would finally meet at a single point. The cost of these works amounted to hundreds of thousands of euros, and the engineers' reputations were irrevocably tarnished. This incident has become a textbook reminder that even in the age of satellite navigation and laser rangefinders, a simple plus instead of minus can turn a bridge into a useless ramp. Let's move on. Imagine a futuristic metropolis, dozens of luxurious skyscrapers with panoramic windows, wide avenues, modern infrastructure, and absolute ringing silence. Not a sound of engines, not a child's laughter, not a single light in the windows. This is Gangsan in South Korea, the Songdo district, which was supposed to be the smart city of the future, but has turned into one of the most expensive monuments to construction miscalculations and human greed. The designers created the perfect habitat for machines and algorithms, but completely forgot about people. The $40 billion project was conceived as a Korean version of Dubai or Singapore. The builders erected the city on land reclaimed from the sea, implementing technologies that seemed magical. For example, there are no garbage trucks. The entire waste collection system is automated, sucking waste directly from apartments through a system of underground pipes. The street lights dim automatically, and sensors monitor every movement on the street. But when the city was completed, it became clear it was uninhabitable. The main mistake of these geniuses was their overscale and sterility. The architects were so preoccupied with blueprints and efficiency that they made the streets too wide and the spaces between buildings too vast. The city turned out to be uninviting, cold, and inhuman. In pursuit of innovation, developers set real estate prices so high that even wealthy Koreans chose to remain in cramped but vibrant Seoul. Gangsan became a concrete desert city, where there are a dozen surveillance cameras per resident and not a single cozy cafe around the corner. Today, this area looks like the set of a post-apocalyptic film. Enormous investments are literally buried in the ground, and investors continue to suffer losses, as maintaining the empty smart systems costs a fortune. Builders have proven that you can create the most technologically advanced city in the world, but if you don't consider the psychology of comfort and social connections, your project will remain just a beautiful but empty box on the ocean shore. This is a profound lesson in how a city isn't just walls and Wi-Fi, but also a soul, something that can't be designed in AutoCAD. Let's move on. Imagine a majestic building designed to house millions of volumes of human wisdom. The library at a prestigious Western university was intended to be a temple of knowledge. Massive concrete walls, high ceilings, endless rows of bookshelves. The project was executed on a grand scale, and the architects took pride in the modernist aesthetic and monumental structure. However, soon after the first batches of books began arriving, the building began emitting ominous sounds. The concrete began to crack, and the foundation began to sink into the ground much faster than predicted. The cause of this construction disaster turned out to be so absurd as to be hard to believe. When calculating the load on the floors and foundation, the architects and engineers took everything into account: the weight of the concrete structures themselves, the weight of the furniture, the weight of the ventilation systems, and even the estimated weight of the hundreds of students who would be in the halls. But they forgot one small detail: they forgot to weigh the books. More precisely, they failed to account for the combined weight of millions of inked paper pages. It turned out that the tightly packed bookcases created a colossal load, several times greater than the weight of the empty building. Paper is wood, and when it's stacked in huge piles, its weight becomes critical for structures not designed for it. The library literally began to sink under the weight of its own knowledge. The floors began to ripple, and cracks large enough to squeeze a hand through appeared in the walls. As a result, management was forced to take emergency and rather ironic measures. To prevent the building from collapsing, some shelves were left empty, and access to certain sections was permanently closed. Today, students at the library observe a strange scene: vast empty spaces, with books arranged in a checkerboard pattern to evenly distribute the weight. This incident has become a byword among construction workers. It's the only example in the world of intelligence literally becoming an unbearable burden for matter. Remember, even the most brilliant idea is worthless if you forget simple physics. So, which of these mistakes shocked you the most? It's hard to believe that billion-dollar projects can be based on such childish miscalculations. If you found this interesting, be sure to like this video. It helps us find even more incredible facts for you. And most importantly, let us know in the comments what you think of these stories. Whose mistake do you consider the most unforgivable? The architect who forgot about the books, or the engineers who couldn't connect the bridge because of the different seas? We look forward to your thoughts, and see you in the next episode.